Good afternoon. I am so excited you could join us today. My name is Captain Melissa and I'm your host for today. This is your teacher, Captain Baker. Hi. We have an exciting lesson to share with you today. We are going to learn all about space exploration. But before we begin, let's take a closer look at our lesson objectives for today. Today you're going to describe the three modulas of Apollo 11 and their functions. You are also going to summarize the key events in the story, Space Exploration, using a timeline. But before we get started with today's lesson, let's review what we've learned so far about Nicholas Copernicus in the previous lessons. Can any of you share any details that you remember from the text that we've been reading? Awesome, great job. He did say that the Earth moved in space. Great answer. Who would like to share another answer? Correct. He did propose the heliocentric idea that the sun, not the Earth, was at the center of the solar system or the universe. Great answer there. He also opposed the geocentric view, meaning, or he thought that it said that the Earth was the center of the universe. Anyone else want to share a detail? Awesome. Copernicus did make all of his observations long before the telescope was ever invented. Great job. Who remembers studying about Galileo? Great job. Yes, Galileo invented and used a telescope to learn more about the solar system. And yes, he gathered further evidence that the Earth was not the center of the universe. Who can tell me what they know about telescopes?
We looked at one yesterday.
Sure did. Awesome job. Telescopes are the only way that astronomers learn about the universe. What's another way? Who remembers? Correct. It is through space exploration. And we know that space exploration depends on who? Awesome. The astronauts in various kinds of spacecraft to explore space in different ways.
Before we start with our lesson, let's talk about some important words and the meaning of these important vocabulary words that we're going to see when we have our lesson. Let's take a look at them. The first word is module. Say module.
Module.
A module is a segment or a section of a spacecraft designed to do a specific job. If you used it in a sentence, it might say, the second lunar module built for the Apollo project moon missions was only used for ground testing and is now on display at the Smithsonian National Air and Space Museum. Module, a gesture would be, maybe let's do a pronged module. Excellent.
Awesome. Great job.
Our next word is spacecraft. Say spacecraft.
Spacecraft.
This meaning is a manned or unmanned vehicle designed to travel into space for research and exploration. In a sentence, it might be used as like this. The International Space Station is an important spacecraft in which astronauts and scientists live and work together.
Awesome.
And let's think of a really cool gesture for spacecraft. Why don't we use two fingers and let it blast off?
Awesome. Great job. What's
Super.
that word?
Spacecraft.
Awesome job.
Our next word is probes. Say probes.
Probes.
This means an unmanned spacecraft sent to explore space and gather scientific information. In a sentence, it might be used like this. After 35 years of space travel, the space probes Voyager 1 and 2 reached the outermost regions of our solar system. Probes. Let's make something that looks like antenna. Probes. That's our word. The next word is space shuttle. Say space shuttle.
Space shuttle.
It is a partly reusable manned spacecraft launched into space for research and exploration that returns to the Earth and lands on a runway. In a sentence, it would be used like this. The International Space Station is an important spacecraft. where astronauts and scientists from all over the world come together and explore space. Space shuttle. Now this is when the rocket blasts off and this part drops. So that is where they actually live, astronauts live. Space shuttle. And our last word is triumph.
Triumph.
Say triumph.
Triumph.
This means a special achievement, success, accomplishment, or a victory. In a sentence, it would be used like this. Being given an award for her story was a special triumph for Caroline because learning to write had been difficult for her. Triumph. We're the winners. We're triumphant. Let's do this gesture. Woo! Great job. All right, now I need you to listen closely to learn more about space exploration. And you're going to be looking at our text as we read.
Are you ready? I want all listening ears. Ready? Let's pay close attention. Just think, Copernicus, with the help of other scientists before and after him, changed our understanding of astronomy when he discovered the universe is not geocentric. Copernicus opened our eyes and minds to a whole different way of thinking about the universe. How were just a handful of people able to come up with an idea that changed the whole world? It's quite simple, really. Copernicus began by studying something he was really interested in, the night sky. His interest led him to make careful observations, to ask questions, to work hard, to study, to think logically, to come up with new answers, and to build upon the work of other scientists before him. His willingness to ask questions, even when he had to stand alone with his ideas, led Copernicus to make an important scientific discovery, that our solar system is heliocentric or sun-centered. All of science is based upon careful observation of the world and a willingness to ask questions about it. Asking questions allows us to come up with new ideas, and new ideas lead to a better understanding about how the world works. That's why the process of science is all about. So, whenever you observe the world around you and ask questions about what you see, you should be proud of yourself because you are thinking like a scientist. Not too many years after Copernicus died, the telescope was invented. As you heard in the previous read aloud, Galileo was one of the first astronomers to build and use a telescope. Very soon, many astronomers began using telescopes to take a closer look at the stars. This gave them new information, and so astronomers were able to learn even more about the universe and gather more evidence that supported Copernicus's heliocentric theory. As you heard earlier, astronomers discovered the planet Neptune fewer than 200 years ago. In 1846, when they were finally able to see it with a more powerful telescope. Astronomers continued building different types of and more powerful telescopes, which led to an even better understanding of space and more questions about it too. Discovering more objects similar to size in Pluto led scientists to ask again, how should Pluto be classified? With more information available, astronomers came up with a brand new answer to that question. Today, telescopes that astronomers use are usually located in areas far away from cities. Where there are cities, there is also a lot of light. And where there is a lot of light on Earth, it is harder to see the light of the stars. Light made by humans that hinders or blocks our view of the stars is called light pollution. Besides building telescopes far away from light pollution, astronomers also like to build telescopes on high mountains. You might think it's so the astronomers can get closer to the stars, but it's not really that much closer. An observatory is a building designed especially for observing the stars, planets, and other space objects. Placing an observatory high on a mountain allows astronomers to get above as much of Earth's atmosphere as possible. And as the Earth's atmosphere thins out in higher places, astronomers can more clearly look at the light of the stars. A more powerful telescope was built for the Lowell Observatory in Arizona for the purpose of finding Pluto. Astronomers thought that Pluto existed before they ever saw it. There appeared to be something in space beyond Uranus and Neptune that was exerting a strong gravitational pull on these planets. Astronomers searched for 25 years before they finally discovered Pluto. But there's another way that scientists are able to place telescopes even higher than the highest mountain. Telescopes are launched into space. That's right. Scientists now use rocket ships or rockets to escape Earth's surface gravity. The power of rockets enables spacecraft to launch the telescopes into space. Once beyond Earth's atmosphere, the telescopes can study the universe more closely and clearly than ever before. Some spacecraft are held in orbit around Earth by its gravity. Other spacecraft have ventured beyond the reach of Earth's gravity to explore other parts of the solar system. Telescopes and cameras aboard the space probes Voyager 1 and Voyager 2 have spent the last 35 years gathering information about Jupiter, Saturn, Uranus, Neptune, and the outermost reaches of our solar system. Telescopes that are launched into space are literally out of this world, and they are able to take pictures of the universe that are also out of this world. The Hubble Space Telescope is the most famous telescope ever to be launched into space. It was carried into orbit by a space shuttle in 1990, and it now orbits about 350 miles above the surface of Earth. Because there is very little light pollution in orbit, and because Earth's atmosphere does not get in the way and cause distortion, this powerful telescope helps scientists see deeper into the universe than ever before. The Hubble Space Telescope has provided scientists with new information and fantastic pictures about our own solar system, distant stars, faraway galaxies, and other celestial bodies and occurrences. New discoveries in science, such as the telescope, always lead to new questions. For most of human history, many of the questions and theories people had about space come from simply gazing up at the night sky. People could look up at the moon and the planets and the stars, but these celestial bodies were completely beyond reach. Once humans invented a way to fly in airplanes, which was only a little more than 100 years ago, the question soon became, can we fly beyond the Earth's atmosphere all the way into space? The exciting answer to that question was a loud yes, and in 1957, a group of countries then called the Soviet Union, which included Russia, sent the first satellite made by humans into space. This satellite was called Sputnik 1, and it was an aluminum sphere that was only about the size of a beach ball. The small artificial satellite began a whole new revolution in space exploration. Can you guess what scientists' next question was? It was this: if we can send a satellite into space, can we also send a living being into space? A month later, Russia sent a dog named Laku into space. Laku was the first living being to ever go to space. After Laku's mission, several more dogs were successfully sent into space. Can you guess what the next question was? Right, if we can send a dog into space, can we send a human into space? In 1961, the Soviets again answered this question with a resounding, enthusiastic yes. The first human being to go into space was Soviet cosmonaut Yuri Gagarin aboard the spacecraft Vostok 1. Cosmonaut Yuri Gagarin orbited the Earth in Vostok 1 for 108 minutes before returning to Earth. With this new triumph, That's our vocabulary. Our accomplishment, scientists ask a new question. If we can send a human being into space, can we also send one to land on the moon? What do you think the answer was? A triumphant yes. In 1969, the United States sent 3 astronauts into space: Neil Armstrong, Michael Collins, and Buzz Aldrin. These astronauts traveled to the moon in a spacecraft called Apollo 11, which had 3 sections. The lunar module of the section in the bottom left-hand corner was named the Eagle, and it landed on the moon with Neil Armstrong and Buzz Aldrin aboard. Meanwhile, astronaut Michael Collins orbited the moon in the Apollo 11 command module, which was called the Columbia. A third service module provided power, oxygen, and water. On July 20th, 1969, Neil Armstrong became the first human being ever to walk on the moon. Soon after his feet, which were inside his spacesuit, touched the surface, Neil Armstrong spoke these famous words: "That's one small step for man, one giant leap for mankind." Soon after Armstrong said these famous words, Buzz Aldrin joined him to walk on the surface, where they bounced and hopped to get around because of the moon's low gravity. The astronauts had to plan their movements 6 or 7 steps ahead because movement on the moon is different from movement on the Earth. They also discovered that the fine moon soil was quite slippery. Together, Armstrong and Aldrin collected about 48 pounds of moon rocks and brought them back to Earth to be studied. They took many photographs and performed experiments to learn about the moon. Neil Armstrong and Buzz Aldrin rejoined pilot Michael Collins aboard Apollo 11's Columbia, where they lived while in space, and they all returned safely to Earth. Thanks to Earth's gravity, the Columbia came back through Earth's atmosphere and splashed down in the Pacific Ocean. There are lots of pictures of the Columbia in magazines and on the internet. And someday, if you ever visit Washington, D.C., you can see the Columbia at the Smithsonian Air and Space Museum. In the past, spacecraft like the Apollo 11 were only able to fly into space and back one time. They were not reusable. But with advances in technology, reusable spacecrafts have been developed. Reusing the space shuttles has saved time, money, and valuable resources. As scientists continue to explore space in the future, we will continue to better understand both space and the universe. As we continue to learn more, you can be sure that there will be many new questions that will be asked. Maybe you'll be asking and even answering some of them.
Guys, come back to us and let's talk about what we remember from the story. Let's see what you remember so far. Ready?
Ready? Are you ready? Thumbs up.
Why are the Sputnik 1 and Apollo 11 trips into space considered triumphs?
Great answer. Sputnik 1 was the first satellite to be sent into space. Apollo 11 was the first spacecraft to successfully take astronauts to the moon.
Super answer. Describe Aldrin's and Armstrong's time on the moon. What were some of the things they did and learned while they were there?
Who wants to answer that one? Awesome. Aldrin and Armstrong practiced walking. They collected rock samples, took pictures, and performed experiments. And you know, what was that? Correct. They learned that the soil on the moon is fine and slippery. And they brought back rocks that could be studied, and they learned about the effects of gravity.
And we remember that from yesterday. What factors are important to consider when choosing the site of an observatory? Remember, that's where we look through a telescope.
Look at the hands going up.
I see
Great.
them.
Let's share your answer. Being high on a mountain reduces the amount of distortion from the atmosphere. Being far away from the light pollution of cities provokes darker skies.
And what is unique about a space shuttle, guys?
That is correct. they are now reusable spacecraft. Good job.
Okay, we want you to take a look at a picture of a module of Apollo 11 so that you can see. So if everybody will put their attention back on the TV screen, there you go, you got it.
Okay, let's look at the top one. This is the service model. The service model is on the top, and that is where your power, your oxygen, and all your water is carried. The second modular, what is that? Correct, that is a command modular. It is in the middle, and it is called the Columbia. And it was the main part of the spacecraft where the astronauts lived and traveled. And what is our last module? Correct, the lunar module. It is on the bottom, and it was called the what? Yes, it was called the Eagle, and it's separated from the Columbia to land on the moon.
So there were 3 parts. Let's say them one more time.
The service module, the command module, and the lunar module.
So now you know, if you ever travel to space, what you might be living and working in. All right, guys, we're going to go back and look. I need you to come back to us, and we're going to talk about a timeline that is going to help us remember the key details. So if you look right here, there are a few little clues for you. But let's talk about what a timeline does. A timeline shares the date of an event. It also tells us what happens and why it's important. You can add images or data or pictures or anything you want. You could even make a timeline of your own, of your life. The main objective of a timeline is to demonstrate a sequence of actions within a particular time frame. So if you started with your life, you would start with when you were born, and you would go all the way up to however old you are today. So let's begin. The first thing that we learned about was in 1543, Copernicus developed his heliocentric theory. Then in 1576, there were observatories. Awesome.
And your timeline can even include pictures, if you'll notice on the timeline.
In 1609, we know that Galileo built and used the first telescope. And there's a clue. And now we're going to skip all the way to time that we were alive in this century. That was long, long ago. So in 1957, we know that the Sputnik 1 had Lyku, the dog, who traveled to space, which made us think that then we could have other people go to space. In 1961, the Russian Vostok 1 was a cosmonaut. And in 1969, 2 things happened. Apollo 11 and the Columbia landed in the sea. And finally, in 1990, the Hubble Space Telescope was created. And so we know, looking back, that this timeline that we made shows us all of the different things that happened during a long period of time.
Okay.
That was a great lesson, guys.
We hope you have enjoyed today's lesson, studying the 3 modulars and creating a timeline with us. We want to thank you for joining us. All rights and credits from this lesson belong to Core Knowledge Language Arts. We would like to thank them for publicly sharing these materials. I have included a list of titles which can help you build your knowledge about the topics that were covered in today's lesson. The first one is Astronomy, Amazing Science Discoveries. You have Astronomy, DK Eyewitness Books. The Hubble Space Telescope, Understanding and Representing Numbers in Billions. Magic School Bus Blast into Space. The Magic School Bus Takes a Moonwalk. Space Exploration. Space Stars and the Beginning of Time. What is the Hubble Space Saw? We would like you to share your timeline with a friend, a neighbor, your mom or dad. Tell them everything you've learned about space exploration. Thank you again for joining us today, and I hope you will tune in tomorrow for
A Walk on the Moon. Bye. Have a great afternoon.